Yeah, so basically, this is the event for you, which means if you have a question, just interrupt, shout it loudly, ask any kind of questions around Nginx products, unit, the company. If you want to change the live demo on the fly, that's even more fun, because let's do it in a more interesting way. So I brought about 4 slides for you. And this is something very simple. The main part of this is going to be just going live into the command line, live into curl and API commands and things like that. So what I want to see right now is just a quick show of hands. Who tried unit at home or at work? All right, so we have a few users here. And who has never heard about it, including didn't even read much on the web? Okay. which means I will have to do a little bit of introduction in the software, in the things that we built and why we built it. Although I was not really planning on going into the very generic things, I wanted to go deep dive, but still. With Nginx Unit, we started working with the application space in the application plane behind the conventional Nginx web servers. We started to launch application code in various languages, using various interpreters or compiled versions of the code. Unit can run apps in 6 different languages. So who can name a few? Let's go. Which languages? Go, PHP, Ruby, Python, JavaScript as Node.js. Java, it's something that we're working on. And somebody said Lua. That is wrong. Unit doesn't launch code in Lua, although this is something interesting that we had as a community request. Okay, so all of those different languages, they are being launched by this application server, and you can create a configuration and manage all of them dynamically the same way. There is no application server in the world that can launch a Go app and a PHP app and provide the same configuration plane for both of those different worlds. Basically, you're taking a legacy app and you're modernizing it by placing it in a different kind of an application server. Inside Unit, you will find an API management. The way how to change anything about your configuration, everything is available through a very simple to use API. Now, what we did initially with the first releases that are about 1.5 years old, we created a concept of a listener inside of the application server and a concept of an application object. And initially, you could only bind listeners to the application objects directly, which means anything that lands on an IP and port is only handled by one app. This is when you put Nginx in front of that system, and you create the level of internal routing through the Nginx location blocks, Nginx server blocks, and different upstreams. What we added with the latest version of Unit is the concept of internal routing. And with the concept of internal routing, what you can do is define which URIs, which host names, and which methods should land into a particular application. This basically takes a bit of Nginx functionality with the routing and brings it closer to the application. In this environment, Nginx will still be doing the ingress portion of your environment. Ingress meaning it's the front end, the very edge of what you're building. And it will be doing some appropriate levels of encryption, different rate limiting, application firewall features, things along the lines of serving static files and so on. And then passing the requests to the application server behind it. Now, when the request is landed on the application server, now Unit will figure out which methods, host names, URLs are in that request, and then we'll forward it directly to the appropriate app. So what makes it different from the routing levels of the original Nginx is that it's not structured. Inside Nginx, you define a server block, which is where you put the server names, which is where you put the host names. Inside of a server block, you put the location block where you define the URLs. Inside the location block, you put the methods through limit accept or any other directives. But the difference is, with Unit, you can define methods, URIs, and host names within the same structure. You don't have to put one inside of another. Here's how it looks in terms of an API. This is a little bit of an eye chart, but it shows a good idea where we are placing just the URI parameter on with the method for the first match. For the second one, we're matching it by the host name and the URI, and for the third one, we just match it with a method with a wildcard. Okay, so which 3 HTTP methods would be covered by the last line, by the last match? So it's P star. Give me at least 3 methods. All right, you gave me 4, even better. Actually, I'm not sure what push is. Put, post, patch. Maybe there is a push. All right, so let's go and see how this software is installed. All right. Let's see what I have running right here. We got the unit process. It's already in the system. And, well, uh-huh.
What is the order? How does it work as far as multiple matches first, or those
first to last. Yeah, yes, the matching goes first to last. Yeah, so in this case, when you are defining a route, you are defining it as an array of objects. So it's just starting from the top and going further. Yeah. Very good question, by the way. So let's get to our source code. Since we have a lot of time here and we are going to go really fast, let me just start from scratch. So we we just cleaned out all the compiled objects. Let me just configure it really quick. So configuration options for compiling unit from source are defined right here. So what I'm going to do is I'm going to configure it with OpenSSL support. I'm going to add a proper prefix, which is going to be my home directory with the unit here. I'm going to give it a very unsafe control socket. So why this control socket is unsafe is because any user within that system is going to be able to access this port. Basically, in production systems, we recommend using a Unix socket, which you can define user permissions to. So not every unprivileged user can use that Unix socket. But for this one, it's going to be just easier to do it with 127.0.0.1, just for everybody on the local host to be able to do anything about it. Another thing that I'm going to do, I'm just going to set it up with my username and my group name. So that looks like the configure command that you're used to. However, that's not all. If you compile it that way, you will not see any of the interpreted languages, none of the interpreted language modules in the system. So what I'm going to do there, once again, I'll show you the help. You see all of those PHP, Go, Perl, Ruby, and so on options. So what I'm going to do, I'll do configure PHP. On top of doing the first configure command, you're doing this, the configure command several times for each of the languages that you might want. So let's do PHP, Perl, Python. But the thing is, I have more than one version of Python. So this is 2.7. That's defined here in the system by default. If I do this, I'll see that for Python, just as for most of the languages, we have a few options there. So there is a Python config in the system. Python config I have at version 2.7 and 3.6. So what I'm going to do, configure Python with the config name, Python 3.6-config. This one will configure a second module for Python. Now, what's interesting is I did not just configure different languages, but also different versions of the same language. For Unit, it doesn't matter what those versions are, what those languages are. It manages them the same way. OK, so now we have it running. Let's compile it once we configured it. It takes a moment. We got a lot of code in. And now let's do make install. And we'll see that we added 2 Python modules, Perl, PHP, and everything was set into home/nic/unit. If you don't like compiling things yourself, you can use our packages that we provide. Those are very easy to find. But compilation enables you to use newer versions of the languages and some of the newer features exactly in the way that you might like them. All right, so we have it installed. I want to do one little thing here. I want to remove the saved config state. So I have unit as being unit D. All right, we have something running here. Let's see if our control socket is available here. So we set it in 127.0.0.1.8.4.4.3. Here we go. That's our API output of unit right there in the browser. What we're going to do now is we're going to push some JSON into that API, and that will enable a few applications and a few other things around the system. I have a few files prepared here. So we got this start JSON. Let me show that to you. I set it up with 3 different applications. So these 3 different objects will be placed right here into the applications object of the config. Let's go ahead and put that in. Let's first see what we have inside of applications. It's an empty object. And then we're going to put just our start.json file right there. OK, so that was quick. What you should see there in our API output that we will have our 3 applications running. You might ask, how do we access those? We might add a listener just for that thing. What do we have in the listener? We have a very simple 8081 listener, and it passes all the requests into one particular application. So the very same idea, what we're doing there is, hold on, curl, let's do the same thing, put, there's going to be our file listeners.json, and we're going to put that into our 127 that 443 config listeners. OK, let's see what's happening here. We got our listener 8081. Is it really listening? We got 8081 listening on the unit router process. Very nice. Also, we have, here's our API, which is listening on the unit main process. If we will look closely here, we will see that we have several different processes that unit runs. By default, it only runs one application process per application, and we got the controller, the router, and the main process. OK, but anyway, So this 8081 thing, it's exactly what I had in my browser page. Here we go, that's index.php, application 1, that's exactly what it's returning. Now, let's move it into the next step. Let's create a few interesting routes. Well, I have a few prepared. So we got the first one, which matches any GET request, and that is what is being passed into the application app1. The next one is more complicated. So any URL that is htaccess URL with a particular host name, that is being passed into the application go away, as we don't want any access to that one. And the other one, it's our match with the different methods. And now it's passing it into the application app2. Now, what is that object? It's just a JSON object, which defines the set of routes by name, very simple name, my. And it is an array of objects right here. OK, so let's do the same thing again. We're going to put routes.json, HTTP 8443 here. That's going to be config routes. Very simple again. Let's see the API output. Our routes are created. Is it going to change our listener? Not so much, because we are still passing all of the requests from the listener just into the particular application. So we need to change this listener's pass object from applications app1, from this object, into routes/my, into that object. That's going to be a very simple thing. It's really easy to do. So let's first look at our listeners. It just has 8081 in the pass object. All right, let's dig one level further and into the pass object. So we got this particular object directly through this URL. All we need to do is we're going to put some different item inside. And instead of application/app1, we're going to put routes/my. All right, that's very simple to do. Now we have all the requests going into that IP address and port routed through the routes object right here, through all of our rules that we created. So let's test it out. 127.0.0.1, we got 8081. That's our index.php of app1. What if we do the same, but with the host name my.org and with the URL that's defined right here? So let's set up the host. It's my.org. And the URL is going to be .htaccess. All right, we got our very bad response with the 500. That's exactly what we wanted there. Probably you want to change your application to something better than 500, but that's good enough for somebody to not like this request. And the next one is going to be the match of the different methods, which means for our 8081 host and port, if we change our method to patch, we'll see that it is returned by a different application with a different method. So what we did there, we changed our sets of routes directly on the fly. And we basically upgraded our simple application from being able to only pass requests from a listener to one app to a set of different rules. So the thing is, those rules can be referring to basically very different sets of apps or to the same app with different security settings. For example, you might want some of the URLs, even though they're handled by the same, let's say, WordPress system, maybe you want one particular host name to be run by fewer processes or by more processes, or you want the uploads to be done by a particular different user of the system. So your uploaded files would have a different permission. Another thing that you can do, you can define the host names, and that is very close to what we can do with the server name directive within Nginx. So all of those things, they are available, and they're absolutely easily configurable there. So the next thing that we can do, and this is one of the newer things for Unit. I wanted to show that because it goes really well with the different sets of configuration, is how to configure a level of encryption with Unit. Because right now it's only serving things on the HTTP port without any SSL certificates. So let's do that, and that's going to be really easy. So what I have here is a bunch of SSL certs, and the one I'm going to use is going to be this one, self.pem. If it's something other than a self-signed certificate, don't show it publicly like that, especially with the private key and stuff. Yeah, this one is not really interesting, but you can take pictures of that and put that on and try to decipher something with it. So anyway, here's our full chain, both the cert and the key in one file. What I'm going to do is I'm going to take that file, and I'm going to put that file inside of my certificates objects, inside of the certificate object here. I'm going to give it a name, and I will define that name in the URL of my request. So that's going to be the put method again. Curl doesn't really like the multi-line files in this sense. It changes the character return. So I have to use the data binary in this one. That's going to be self.pem, and that file is going to be landing on HTTP 127.1.8.4.4.3, and instead of config, that's going to be certificates. And let's give it some name. Let's call it meetup. It takes a moment, just a tiny bit more than launching an application. There is a bunch of checks here. So let's refresh our API. Here we go. That's all that we just did within that cert. We can see it directly in our API. So imagine the thing here. You got your new Let's Encrypt cert. It was just created by some dynamic system. You got it in your hands, and you need to replace the cert on your server. Usually what you do is you place a file in place of your old file, and you restart your server or reload things like that. With this one, you just push a new one through this API, and that's instant. This is not restarting or reloading any of the application processes. The networking and security level is totally decoupled from that. So what we're going to do here, we can either change this listener to be the SSL listener instead of plain HTTP, or we can create a new one. What do you like? A new one for that, or this one? Huh? New one? Okay, let's do a new one. That actually makes sense. We can give a nicer port number to an SSL-based thing. So what we're going to do is we're going to do the same put command. I'll put the URL first, 127.1.8.4.4.3. That's going to be listeners. And 8, let's do 1.4.4.3 since 8.4.4.3 is already taken. This one, and then the data. So the data is going to be an object which will have a pass, and then it's going to have a TLS object. Okay, so the pass will send us to routes/my, the TLS object is going to have a certificate parameter, and the certificate parameter value will be the meetup. Okay, I made some mistake here. Huh? Hold on. No, not exactly. I have not created the listener and started to put objects into that. So let me do this. So let me just grab all of the listeners. Oh, hold on. I see what I did wrong. It's config/listeners. This one. This is better. All right. So we have this one on the port 1443. Let's try it out. 1443. And that's going to be error because I did not specify HTTPS, and my browser doesn't know anything about this port. Here we go. Advanced, proceed. We got our certificate right here. That's the one. Okay. So what we did here, we just created a different type of connectivity to our sets of application. We just changed the routing of different apps. We just created them based on URLs, so based on host names and methods, and all of that without ever restarting anything on the application server or without ever restarting any of the applications themselves, which makes a lot of sense for some longer running things, for something more sophisticated than a simple PHP app. Okay, so at this point, let's open for questions. And with the questions, if you want to see something done, if you want to try something on this system, just ask about it, and we'll just try to do what you want with this nice system. Yep.
Well, I feel special now. But will it support SNI and a sort name indicator to choose which certificate to use to process the request?
SNI is planned. It's in the roadmap. It's not supported as of today, but it will be supported at some point in the roadmap. Mm-hmm. Mm-hmm.
How does that compare to PHP FPM? It's like performance and capabilities.
Performance capabilities, we did not check all of the different types of bake-offs against all of the application servers in the world, so I don't have full numbers or on anything other than just very few things that we done there. And as far as comparison to PHP FPM, Unit is generally more lightweight. And if you run more different languages and more different types of applications at the same time, you actually cannot do that with PHP FPM. Although it's a well-known server, another thing that we are doing, we're fully HTTP compliant. So any reverse proxy that doesn't do the FastCGI protocol, it can talk to Unit directly. Even the browser can talk to Unit, as you can see right now. Yeah, so there are some different use cases compared to PHP FPM. Mm-hmm. There is another thing that I heard about PHP FPM. If you are running a hosting business with lots of smaller users or smaller user websites on the same machine, in PHP FPM, once you create one pool, a set of different pools for each of your applications, if you change one pool, one setting in one pool, you have to restart the whole thing. With this one, you're just making changes to a particular object, to a particular application without touching the rest of the system. Mm-hmm. Raj, you had a question here and here.
Well, thank you, Nick. I like your yoga thing. I think one of the best thing I noticed today was the listener and the routing. And I think my question is, if you look at my first language I learned was Fortran 4, which was 1970. And at that time, we had only one object-oriented language at UC Berkeley. And we had about more than 3,500 human languages, which were like German, English, Spanish, Chinese, Mandarin, Polish, whatever you call it. But today we have more ways of writing the code than we had like 40, 50 years ago. So I think I like this concept of listener, because what you're doing is you're routing, listener is routing to specific language. So there's no A/B testing problems with the code, because people write codes in different ways. There might be syntax errors, different, higher level languages. I wanted to address that issue, but how do you expand this listener and routing thing, which is, I think, a great concept. This is my opinion.
Thank you. Yes, there are different types of languages that we can run. I can give you a very nice example on that. And this will be an example from the world of Go apps and Node.js compared to PHP, Python, Ruby, and other interpreted languages. So what's the big difference there? For PHP, Python, and such, there is a ready interface within the specification of the language that enables the web server communication to that language, to the runtime. However, when somebody is creating an app in Go or Node.js, conventional way of doing that is to run the app itself, and the app itself will be listening on a port. So you might ask, why do you need an application server there? This thing is already an application server. And that's what we hear a lot from those language developers. What we did there, we created a concept of an external app. And with the external app, what Unit does, it starts up that application that was compiled specifically for Unit. If that application is launched by Unit, it will not listen on a port. It will not open a socket. It will be communicating with Unit for the networking layer. So that is a big difference. We are taking the networking layer from the Go apps and placing them in the application server. Taking the networking layer from Node.js apps, placing them in the application server. Okay, some of the Go engineers say, okay, our stuff is more configurable and it's better, we can do other things with it. But when you bring it to the operations team, operation teams, they value consistency of management more than some of the things that people can tinker in within the code of their apps. It is actually beneficial to take that layer out and make it a consistent networking layer across a variety of apps. And this is what we provide. So technically speaking, from Unit perspective, there is no difference between what kind of executable is the external app. We have examples, we did those experiments with a pure C app written in C that works with Unit. So one of those Unit processes would be a custom written C app. We can do that in anything that compiles if the application is able to understand the shared memory-based protocol of how Unit communicates with the other binary. So technically speaking, if you write a Fortran code that will compile and will talk through shared memory with Unit, that will be working through the system just as any other language. I hope I answered the question.
Thank you, Nick.
All right, so experiments time. What do you want to change here? Any ideas? Do you want to run something else on this machine? All right.
It's not really an experiment. Would you be able to show an example of the Go app, of what a Go application would look like in integrating with this?
Yeah, that's a good idea. So what I didn't do, I did not compile the Go app. So what I'm gonna do is configure Go. It's gonna live in a different directory. Oops, hold on. Make clean. Configure I started with OpenSSL. Let's do configure Go, and I had the PHP on. So in this case, we'll just run a few of those PHP apps and one Go app. Let's do make all. The next one is going to be make install. We don't know yet how to make a graceful replacement of the unit binary. It's also on the roadmap, but we haven't done that just yet. Hold on, we need to run unit as being unit D. Okay, so what we did here with make install, we moved the Go packages into /home/nic/demo/go into this directory. What I'm going to do there is home nic demo go. If we look at the SRC in the SRC directory, we have some unit packages for Go installed in the directory that we provided. What we need to do, since it's a new version of unit, we need to remove the binary and compile it again. So I need to do go build what's -o fc.go. Does that look correct? I haven't done that in a couple of months. Yeah, looks all right. So what's gonna let me show you the code actually. So in the code, in addition to net HTTP, we are adding nginx/unit as a Go package. And instead of HTTP listen and serve, we're using unit listen and serve. So I'll show you that how we run that application two different ways. So first, I'm going to just run it directly. Oh, did it run? Yes, it's running right here. So it's supposed to be listening on port 8000. So let's curl 127.1, 8000. And I had that application converting from Fahrenheit to Celsius. So if I give it the parameter 72, that should return something like 21. Yeah, 22, that. So that application is working. Let's kill it. Hold on. Yeah, it's killed. Now let's launch that same application through the unit system. So our unit is running with all of those apps. Let's create a new application. -x put. Let's give it 8443 config applications. Give it a name. Let's. I don't know. And the data that we will put there is going to be an application. It's an object. So the type of an object is going to be external. OK. And next parameter that we have to define is going to be executable. And the executable will have to we will have to put the full path home nic demo go /fc. Oh, I did not put something. Oh, OK. I forgot to put the -d to define the data. Here we go. Let's check. Is it here? That's the match. That's our application. Let's see. Yeah, application process is running. OK. Do you want a special route to that application? So just a special route. Let's make a route based on host name. That's going to be fun. So what we're going to do is First, I'm going to check the routes themselves. So that's going to be routes my. And then I'm going to just change my second route object. That's method push something, my to match method. Okay, so that thing I will change to get. Oops. Match. Hold on. Oh.
Sorry.
Hold on. Export. Hold on. Curl. That's P. So that should. That was actually supposed to work. I'll see why it didn't. Let's create routing. Let's add it right here. So we're going to just copy that as another different route. And this one is going to be based on host with the host value of convert. And that's going to be our application with this beautiful name. So what I'm going to do is I'm going to put those routes in again. Did we get them in? Here we go. So basically, if I ask for that same application with the local host name, local host. Yeah, that was 1443, this one. So that returns an application app1. But if I do that with the different header, with the host header, that's different. Host convert, that one was supposed to give me the different route. Oh, I see what happened. We matched something else first. We matched this first route object before we matched the other object. So that means let's get rid of this route object, and then it's going to fall down to the last one. And that actually answers one of the first questions about what is the order of matching. We matched the first one, so the last one was not matched. Let's kill the object number 0 from the routes. That's going to be delete. HTTP 8443 config routes. Oh no, that was routes/my/0. Routes my. Okay. So the delete method should have worked. That's a bug. Thank you. I'll have to kill it in this thing and then just delete it separately. I could, or I can just change this URL to something that's unworkable. Okay. That means our convert host. All right, that works. Nice. So now we know that 24 degrees Fahrenheit is -4.4 Celsius. So yes, that worked, and also we found a couple of very nice bugs. So thank you.
And the match that you put in your routes, that can be any header, right? You can pick and choose any header, or even parse a cookie, or take a deeper look into the HTTP header for your match rule.
As far as today, we only support the host header, and we support the host header as one special value. We are planning to add the full header supports. We will also add the support for source and destination IP addresses, and support for cookies and URL arguments. Right now, we're not looking into the URL query. We're just doing the URL before the query. But yeah, so all of those things, they will be developed in the short term. Mm-hmm. All right. I guess we succeeded with our experiments. Thank you.